Okay, this is a full walkthrough of the Momentum and Collisions lab. I know that, well, Flash is Flash. What can we say? So here we're going to first answer a pre-lab question. Don't forget to do that. For some reason, people seem to miss that one. And then we're going to go ahead and open up this simulation. You're going to have to try several browsers. I'm actually using Internet Explorer for this one, and I'm not a huge fan of Internet Explorer, but it kind of is what it is. Now what we're going to do is we're going to go ahead and check some boxes. So let's pop over to the simulation, get this thing a little more on there. And now what we can do is we can make sure these guys are checked. And here I've checked that one, checked that one, checked that one. And in a little bit it says make sure that these guys are 100% elastic. And then we're just going to go ahead and we're going to do some collisions. First thing I'm going to do is I'm going to set my masses to be equal to each other. And I'm going to have ball number 1 with an initial speed of 1 and ball number 2 with an initial speed of 0. That's going to match what the lab tells me to do. We can go ahead and record the ball's initial and final velocity, so it's going to be up to you to do that. You're going to have to probably pause the value, and I'm doing this run right here just now. So masses are equal, initial velocity 1 and 0, and then I'm going to go ahead and do one with -2 velocity. So let's go ahead and check this guy out. So we'll hit the play button, and it's up to you to record the value. So this is before and afterwards. Okay, now we can go ahead and set this guy to 1 and what did it say to do? -2. So -2, and we can go ahead and record those values for your initial and afterwards. And then last but not least, we have an initial velocity of 1. This one had a 0, and this one had a mass of 1. Let me just double check and make sure that we're all on the same page. We're on this guy just right there. So let's go back and run this simulation. So this is before, and that's kind of the afterwards. Now when you come over to the lab, then what you can do is you can go ahead and have the Excel spreadsheet I provided you do these calculations. That Excel spreadsheet should be just right here. And all you have to do is put your values in for initial mass and so on and so forth, and it'll do it for you. So let's go back to the Word document so it can do all those calculations for me. Please do show me a sample calculation of each one so I know that you know what's kind of going on. And then, again, these guys are also in that table. Again, show me one sample calculation of each one. Now what we're going to do is you're going to answer some questions, and then you're going to move on to inelastic collisions. And I'm essentially going to do the same 3 runs where I have an initial velocity of 1, initial velocity of 0, and masses are equal, and then 1, -2, and then 1, 0, but the mass is increased to 1. So let's pop back to our simulation. I'm going to reset this guy, and I'm going to change my mass back to 0.5. And I'm going to start off with a velocity of 1 and 0. Only this time I'm going to go ahead and I'm going to turn the elasticity to all the way inelastic, and they're going to stick together. So this is the before, and this is after. Now I'm going to go ahead and give this one a -2 velocity, so I'm doing run number 2 right here. Masses are equal, and this is before and afterwards. And then last but not least, I'm going to set that guy to 0. I'm going to set this guy to 1. I'm going to hit play. This is the before, and this is the after. Again, we're going to come back to these guys right here, and you can go ahead and calculate these guys using the Excel spreadsheet. What you should notice is these guys are all 1, and these guys are not all 1. When we were taking a look at it up here, these guys were all 1, and these guys were all 1. Kind of the difference between elastic collisions and inelastic collisions is momentum and energy are conserved in elastic collisions, therefore the ratios was 1. It was the same before and afterwards. In inelastic collisions, momentum was conserved, so all of these guys were 1, but these guys were not. So that energy went somewhere, deformation, heating up, sound, something like that.